Um, First of all, one may ask, we've heard of mole concept, and then some of us have even seen it before. What is mole, or what is amount of substance? So the mole is defined as the amount of substance which contains as many particles as there are carbon atoms in 12 grams of carbon 12 isotope. That is the definition for a mole. So the unit for the mole is MOL. That is the unit for the mole. And then the symbol for mole is small n. Small n. So in a mole or in a particular amount of substance, we have individual elements of this substance, and these are particles of the element. The particles of these elements can either be atoms, you can have the molecules, you can have the ions, and even electrons. So, like I mentioned earlier, the mole or the amount of substance contain as many particles as there are in carbon atoms. So when we talk about mole, particularly the reference go to C atoms or carbon atoms. Normally you will hear of, you have carbon 13, you have carbon 12, and carbon 14. But with a mole, we are dealing particularly with carbon 12 atoms. According to or in attending to the mole concept, there are particular things or individual things you need to pay much attention to. What are some of these things? The first I would want to mention is relative molecular mass or relative atomic mass. So for the relative atomic masses, these are masses that come along with our elements that we have on the periodic table. So most of us have, or we've heard, or some of us have seen that normally you are being told that the molar mass or the relative atomic or molecular masses of, say, carbon is 12. The relative molecular mass of, say, hydrogen is 1. These are some of the things that you need to pay attention to when you are attending to the mole concept or the amount of substance in the mole. Sorry. Oh. Please, a minute. I think my screen went off. Oh, Mr. Isaac, can you kindly help me a little? Can you see my screen, please?
Yes.
Yes, sir.
Yeah,
Okay.
sir. Your screen is clear. Everyone can see that.
Okay. I'm not seeing it here. I don't know.
You're unable to see your screen over there.
Yes,
Uh,
I'm coming. Okay.
I think you should just stick to your PowerPoint. I mean, you should stick to the interface at PowerPoint because it's clear here. If you want to see if they
Let me
can
show you.
see what you're sharing, you can come back to Zoom. Now we cannot see your screen. Yeah.
Okay.
Yeah.
Can you see my screen now?
It's loading. Now we can
Oh,
see. Yeah, we can see. It's clear. Yeah, we can see your screen.
things you want to pay much attention to. One of these things are the relative, like I mentioned, the relative atomic masses and then the relative molecular masses. So with the relative molecular masses, I made mention of the fact that these are elements on the periodic table have these relative molecular and atomic masses attached to them. So normally you hear that you have carbon, which has its relative molecular mass to be 12. you have, say, hydrogen, which has its relative molecular mass to be 1. So please, one thing that you need to know is that normally during the examination, these relative molecular masses and atomic masses sometimes are not provided because it is assumed that the student should have them at the tip of their, on their fingertips, because repeatedly solving more questions on mole concept should get you used to some of these things. So as time goes on, we'll be taking more questions, we'll get used to some of them. The ones that will be new to us, we introduce it and then we learn it alongside. Also, aside the relative molecular masses and atomic masses, we also pay much attention to molar mass. So the molar mass of a compound. We can have a molar mass of an element. The molar mass of an individual element becomes its relative atomic mass. So the molar mass of hydrogen is 1. Hence, that is its relative atomic mass. Molar mass of carbon is 12. That is its relative atomic mass. So the molar mass of a compound is the mass of 1 mole of the compound. So if you have carbon dioxide, the molar mass of carbon dioxide is the mass of 1 mole of carbon dioxide. If you have ammonia, which is NH3, the molar mass of ammonia is the mass of 1 mole of ammonia. So you can see that when I mention molar mass, I mentioned mass and I mentioned the mole, which means the 3 things are interrelated or they are interconnected. For me to be able to find for the molar mass, I should have the mass and also I should know the mole. That is using the formula that is used to find for the molar mass. The unit for molar mass is gram per mole. That is what I've put here, gram per mole. Please, a minute, let me see if I can use a cursor. So the molar mass is gram per mole, like you can see here. I'm sorry, the unit for the molar mass is gram per mole. So like I was stating initially, I told you that molar masses of individual atoms are their relative atomic masses. And then relative molecular masses are also the molar masses of particular molecules. Relative atomic masses and relative molecular masses do not have unit. It is normally, we denote this by writing the atomic mass unit, AMU, after them. If you write them without any unit, that is molar, relative atomic masses and relative molecular masses, you are not wrong. Also, one other thing we consider, or one of the key things we also look at when we are looking at mole concept, is Avogadro's constant. The Avogadro's constant, okay, so a quick reminder, this particular Avogadro's constant is normally repeated or brought in the exam because students don't pay much attention to it. So they ask you, define the Avogadro's constant. And the unit is capital L. That is, sorry, the symbol is capital L. The Avogadro's constant does not have a unit. The Avogadro's constant does not have a unit. So the Avogadro's constant is defined as the number of particles per unit mole of a substance. So the number of particles per unit mole. If you look at this one too, we are relating Avogadro's constant, we are relating number of particles and then a mole. So you see, when we took the molar mass, we saw that molar mass is related to the mass of the compound and then the mole of the compound, or the mass of the substance and the mole of the substance. When you come to the Avogadro's constant, it's related to the number of particles. Number of particles. This number can either be number of molecules or number of atoms. It can even be number of gases. And also the mole of the atom, the mole of the molecule, or the mole of the gases. I hope you are clear. So 1 mole of an Avogadro's constant is equal to, it's a constant. So it's equal to 6.023 times 10 to the power 23. 1 mole of an Avogadro's constant is equal to 6.023 times 10 to the power 23. That is for the Avogadro's constant. We are going to look at some calculations that involve or that revolve around whatever we've spoken so far in slide 1. Okay, so like I mentioned earlier, so the Avogadro's constant is 6.023 times 10 to the power 23. So if you have an oxygen gas, a mole of an oxygen gas, 1 mole of that particular oxygen gas is equal to 6.023 times 10 to the power 23. And also, 1 mole of an oxygen atom is equal to the same 6.023 times 10 to the power 23. So, like I mentioned, Avogadro's constant has a relationship with the number of particles. And these number of particles can either be the gas, the molecule, or an atom. So 1 atom, 2 atoms, a particular gas, number of molecules. Okay, so let's have a trial question. The question says you should calculate the molar masses of the following compound. So this particular question, the question 1, takes us back to what we spoke about initially, the molar mass, not the relative molecular masses or the relative atomic masses, but rather the molar masses. So in order to find for the molar mass of a given molecule, if you look at the solution for the first example, water, the atomic mass of the molecules that make up water, you have hydrogen and oxygen. The atomic mass for hydrogen is 1, and then the atomic mass for oxygen is 16. So if you look at water, water has 2 atoms of hydrogen and then 1 atom of oxygen. So first of all, you have 1 multiplying the 2, which is the subscript of the hydrogen. So 1 multiplying 2 as a component plus 16, giving us 18 gram per mole. So the molar mass upon calculation is 18 gram per mole. First of all, you have 1 multiplying the subscript of the number of hydrogens, which is 2, then plus 16, which is the relative atomic mass of oxygen, giving us 18 gram per mole. Now, the very next question is sulfuric acid, which is H2SO4. So for H2SO4, we can see that we have 2 atoms of hydrogen, 1 atom of sulfur, and then 4 atoms of oxygen. So like we did for the water, now we multiply 1 by 2, which is the number of atoms of hydrogen, plus our sulfur, which is just 1, so plus 32. Then plus 16 by 4, which is that of the oxygen, giving us 98 gram per mole. So you take your number of hydrogens, which is seen by the subscript 2, so 1 by 2, and then plus the next atom is sulfur, so 32. The relative atomic mass for sulfur is 32, so plus 32. Then plus 16 by 4, 16 for that of oxygen, and then you have 4 times that atom, so 16 by 4, giving us 98 gram per mole. If you can see, there is something that runs through the very first question, second question, and the last question. Would anyone mind to tell me, look at the answers for the first, the second, and the third, and tell me what runs through the answers. Would anyone be able to do that? Hello, please, can you hear me?
Yes, please, you can hear
Yes, sir.
me.
Okay.
Yes, sir.
Okay. So, looking at the answers, what do you think runs through the just the answers alone? 18 gram per mole, 98 gram per mole, and then 106 gram per mole.
Look at ground per mole.
Exactly. So it tells you that the unit for the molar mass is very, very important. If you put 18 what? 18 mole or 18 mole per dm cube or what? Once you are speaking about molar mass, you have to indicate your unit. And that tells you that, yes, we are referring to molar mass. If you look at the very last example, that's the sodium carbonate, sodium carbonate. You have 2 atoms of sodium, 1 atom of carbon, and 3 atoms of oxygen. So you have 23 times 2 plus 12 plus 16 times 3, which gives us our final answer, which is 106 gram per mole. Please, do we have any problem with what we've done so far? Please, do we have any problem with what we've looked at so far? Okay, so now I am hoping we all understand what we've done. So there are a few questions that I would want us to try our hands on. If anyone has any question, you can ask before we proceed, please. Okay, so let's try our hands on these questions. We have the first one is glucose C6H12O6. Please let's try our hands on it, and then one person will unmute and tell me the answer. I hope you are working.
Yes, please.
Okay. So let's kindly try our hands on this, and then someone will mute and tell me the answer. Please, is anyone done?
Yes, please, I am done.
Okay, so
Yes, sir.
okay, Abigail, please, what did you get for the first question? That's the C6H12O6.
Okay, so I got 180 grams per mole.
Okay, that is right. 180 grams per mole. Please, is everyone getting 180 grams?
Yes, sir.
Okay. So you know that carbon is 12. So you have 12 times 6, right?
Yes.
Okay, 12 times 6. And then plus we have 12 times 1, which is for hydrogen. And then plus 16 times 16 times 6. And then that gives us 180 gram per mole. Are we all on the same page? Okay, now let's try our hands on the second question. Let's try our hands on the second question. The second question is sodium carbonate decahydrate. So let's try our hands on it. I know this one might look a little bit tricky, but let's try our hands on it. When we finish, I'll help you out if you are finding difficulty with it. Please, is anyone done?
There. It's plenty.
Okay, I'm waiting.
So
I'm
I
waiting.
don't know. I got
Okay,
so let me be sure first. So I'll come back.
okay, no problem. Be sure of your answer and then mention. Are we done? Hello?
No, sir.
Okay. So should we do this together?
Yeah, please let's do it together.
We should do this one together.
Yes, sir.
Yeah.
Okay. We'll do this one together, but the very next one we'll not do together.
Yes.
Yes, sir.
Okay. So when you look at this, there is a little bit tricky aspect of this particular question. It's sodium carbonate decahydrate. So I know the problem is coming from the decahydrate. If it was to be the sodium carbonate, most of you would have done it already. So let's do this. You have sodium, which is 23, right? Multiplying
Yes.
2 plus 12. Our carbon is 12. Do we all know that?
Yes.
Yes, sir.
Okay. And then how many oxygen atoms?
3.
3.
Yes, so
3.
exactly. So we have 3 times 16. Then plus. Now, the problem with this particular question is you are seeing 10 moles of water. I remember or I recall that in your mathematics lessons, when you were treating algebra and then even if I'm to be right, algebraic expressions, you were told that A times A is equal, sorry, A into bracket 2, it means you are multiplying the 2, right?
Yeah.
Yes.
Exactly. So it means if you see 10 in front of that of water, the question is telling you that find the molar mass of water and then multiply it by 10. Yes. So you find the molar mass of water and multiply by 10. What is the molar mass of water? So let's put our 10 first and then bracket open 1 times 2 plus 1 times 2 bracket close plus 16 so let's put a bigger bracket, which means that the 10 is multiplying everything in the bigger bracket. Do you understand this?
Oh,
Do you understand what I'm doing?
Yes, sir. So it means the 10 is multiplying the 1, the 2, and the 16.
So no. So what it means is that you first of all find for the molar mass of water. And molar mass of water, let's even ignore the 10. What is water? Water is H2O. So H2O will mean that you have 1 times 2 plus 16. So molar mass of water in all will be 18. Do you get it? So the 10 is multiplying everything in the bracket. That is everything done together, the summation done together. So 2 plus 16 is 18. So 10 bracket open 18. It's not multiplying the 1 times 2 and then not multiplying the 16. Am I clear?
okay. Yes.
Okay. So for you not to be confused, you can write the water somewhere, do the molar mass there, and then just bring your value. If you are to do that, this is what you have. You have 10 brackets open 18. So 10 into bracket 18. Because if I tell you to find for the molar mass of water, what will you get if you are to find for the molar mass of water? The molar mass of water is 18 because it's 2 plus 16, 18, right? Yes. So this is what you will get. You have 23 times 2 plus 12 plus 3 times 16 plus 10 into bracket 18. Do we understand?
No, sir.
Okay. Let me go back. So for the sodium carbonate, we understand, right?
Yes, sir.
For
Yes,
that,
sir.
okay. Now the problem is with the 10 moles of water. So the 10 in front of the water is telling you that after you found for the molar mass of water, the 10 is multiplying that molar mass of water. So let's ignore the 10 for now. Let's just put plus 10 and then leave the 10, but then find the molar mass of water. So the 10 is multiplying the molar mass of water, which is going to be our molar mass of water. You have 1 times 2 plus 16. And it will give us what? 18.
18.
Yes. So we know that 1 times 2 plus 16 is giving us 18. But that 10 is multiplying this molar mass of water. As you can see, 10 moles of water. So that 10 is multiplying the molar mass of water. So we'll have our molar mass to now be, our molar mass will now be 23. 23 times 2, 46, right?
Yes,
Plus,
46.
yes, plus
Plus
12 plus
48.
48
8.
plus what again?
The plus
Plus
the
180.
Plus
180.
1, yes, plus 180. So what is our answer? Someone should do the summation.
286.
286. So what is your molar mass for sodium carbonate decahydrate? What is your molar mass? Exactly, that's what I was looking for. 286 gram per mole. Do we understand?
Yeah.
Do we
Yes.
understand?
Yes, sir.
Yeah, please, if you have any question, you can. Does anyone have any question? You can ask if you have any question, please. Okay, now let's do the calcium carbonate.
So I got 100 grams per mole.
For the calcium carbonate, 100 grams per mole.
Yes.
Is everyone getting 100 grams per mole?
We are not solving.
Yes, sir.
Okay, solve it. Please, everyone should partake, okay? Make sure you are partaking. Practice it because it will make you perfect. Practice, make man perfect. So everyone on board should partake, please.
Is equal to or 3.
Please, I got the same answer. 100
You got the same answer, okay?
Yes.
That's brilliant.
6 calcium 12 times 80 and is just
Please, can you kindly mute yourself? Who is speaking? Seth, is it you?
yes, sir, but I've muted it.
Okay. Are you done? What did you get? Seth, what did you get?
Say, I'm not done.
Okay, we are waiting for Seth so that we can continue. Seth, we are waiting for you, so please hurry up.
Sir, please let's do it together.
Okay, so Seth,
Yeah.
you can see that looking at the examples we've done, here
Yeah.
we have 4 calcium carbonate, and then the question is telling us that we should take calcium to be at 40.0. Carbon we already know is 12, and then oxygen
Okay.
is 16. So 40 plus 12 plus 16 times 3. What will you get? Seth, what did you get? Can you see my screen?
Yeah, I can see your screen, sir.
Okay.
40 plus 2. If yes.
What did you get? Seth, what did you get?
Okay. 40 plus 2 is that. A minute, sir. 52. 52. 6 times 16. 16 times 3, 48, 52, 50 plus 48. So it will be 100 grams per mole.
100 grams per mole. That is right. Okay.
So
Let's look at the very last question that we have on this. We have C14H9Cl5. So let's do it. Let's do it together, please. Let's do it. Everyone should be on board.
C14.
C14H9Cl5. The relative atomic mass for Cl has been given in the question, 35.5. Yes, please, what do you have?
I got 354.5 gram per mole.
354.5
.5
gram per mole.
gram per mole.
Okay, that's what you got.
Yes, sir.
Okay. Okay. Seth, are you there?
Yeah, I'm here.
Okay. Are you solving it?
Yes, please.
Okay. Let's solve it. We are waiting for you, Seth. Is everyone getting it? Getting 354.5?
Yes, sir.
Okay. Let's wait for Seth. Seth will finish right now. We'll continue. Please. Seth, are you done?
No, sir.
Should we solve it together? Or you want to finish this one?
Let me finish this one. 1 minute, sir.
Okay. I'm waiting for you. So, please, now, are we all getting used to how to calculate the molar mass when the compound is given?
Yes, please.
Okay. So, if you are given a compound, you can calculate the molar mass, right?
Yes.
From here, we are going to look at how to relate this molar mass, the mole, and the mass of a compound. How to relate these three together. So please, there is a need for you to keep this at the back of your head. You shouldn't ever forget how to calculate for the molar mass of a compound because you will need it. Because we are now building gradually on this. Now we'll build on how to use the molar mass, or when you have a question, how to fish out the compound, calculate the molar mass, and then now use the molar mass to do something or to find something else in the question. Okay?
Okay.
If you have any question, please, you can ask. Okay? Let's give ourselves a minute while we wait for Seth to ask any questions that we have. So, Seth, are you done?
Yes, I'm done, but I'm not getting the answer. So, student network 12 times 14.
Times
14.
12 times 14.
14, yes, sir.
Yes, times 14. And then that plus
84. Yeah.
plus 9, which is 1 times 9. Then
Times
plus,
okay.
oh, sorry, plus 35.5
5 times 5.
multiplying 5, yes.
Yeah.
So we have 354.5 gram per mole. Oh,
85.
okay. Please, are we all on the same page? Are we all on the same page, please?
Yes, sir.
Okay. Okay.
Yes,
So now
sir.
let's proceed. Seth, please, I hope you understand.
Yes, sir.
Okay, so now let's proceed. Now we'll move on to calculating for okay, so now we are going to use whatever formula I gave or whatever I stated initially in the slide 1 about the Avogadro's constant. Oh, I'm coming, please. Let me rectify this. Okay. So like I mentioned, we are going to use or we are going to calculate for the number of molecules, number of atoms, number of gases using the Avogadro's constant. So like I told you, the Avogadro's constant, I mentioned here that the Avogadro's constant is defined as the number of particles per unit mole of a substance. And what is this? What is this number of particles? The number of particles is 6.02 times 10 to the power 23. The Avogadro's constant, like I mentioned initially, has no unit. Okay, so let's look at this. The question says that how many atoms are there in 0.3 mole of sodium? How many atoms are there in 0.3 moles of sodium? What do we have here? We have the question is asking us to find for the number of atoms. The question is asking us to find for the number of atoms. Then we have the mole, which is 0.3. We have the mole, 0.3. And then we have the Avogadro's constant itself, 6.023 times 10 to the power 23. So what do we know or what do we do? We write down our parameters. But before that, the formula for finding the number of particles or the number of molecules of a given, say, substance or a given compound or a given atom is N, which is the number of particles or number of atoms or number of molecules, is equal to small n, which is the mole times the Avogadro's constant, capital L. Please, do we get it?
Please go over again.
Okay. So I'm saying that in order to calculate for the number of molecules, number of atoms, number of gases, or whatever, using the Avogadro's constant, we have the formula capital N, which is the number of, say, molecules or atoms being equal to small n, which is the mole, and then the capital L, the Avogadro's constant. The capital L is a constant. This capital L is a constant. That is what is being stated here.
Okay.
And you
So it
need to
doesn't
know this.
change.
No, it doesn't change. It doesn't change. Upon repetition and upon solving more questions, you have this capital L at the back of your mind. You wouldn't need to always refer to your formula book or something to get it. The capital L doesn't change. What changes here is this, and it changes with respect to this. So if you have capital N and you are being asked to find for small n, you should be able to do it, because if you have capital N is equal to small n times capital L, and you are being asked to find for small n, you just divide here by capital L, divide here too by capital L. So this L cancel this L. Now your n will be equal to capital N over capital L. Do you understand? Okay.
Yes.
Yeah,
Yes.
Konu, Andrews, you have raised your hand. You can ask your question. Andrews, your hand is up. Please unmute and ask your question, please.
Hello. What I'm saying is, in such cases, would the
Oh, I'm not hearing you.
I'm asking that in such cases, would the constant be given?
Yeah.
Or
The
just
constant
have to
is
write it
always.
down?
Come again, please.
I say in such cases, would the constant be given, or we just have to write it ourselves?
Oh, okay. So
We have to
the
rely
constant
on-
will be given to you. In every question, the constant will surely be given to you. But you see, sometimes the constant is given at the end of the question, and you might even end up not being able to locate where it will be given. Or a couple of constants will be given. Maybe they'll give you the constant for this, they'll give you the constant for that. So in order for you not to be using the wrong constant or the wrong thing, just upon solving a lot of questions and upon repetitions on your own, you will know the constant, you get used to it. So the moment you see that it's an Avogadro's question, you know that the constant L is equal to 6.02 times 10 to the power 23. Do you understand?
Yes,
But in any case, the constant will be given to you. Okay? Okay. Yes. So like I said, now if you have a question like this, how many atoms are there in 0.3 mole of sodium? Sorry, of sodium. You have your mole. The mole is given. And then you know your Avogadro's constant. So what do? The formula is N is equal to small n times L, where capital N is the number of atoms that we are looking for. So you have small n is 0.3 mole, capital L is 6.023 times 10 to the power 23. And then now the number of atoms, which is the capital N, will be equal to 0.3 times 6.023 times 10 to the power 23, giving you 1.806 times 10 to the power 23 sodium atoms. That is your final answer. Sodium atoms. Supposing the question asked you to find for the number of molecules, you would have written, maybe if it's sodium hydroxide, you say sodium hydroxide molecules. You cannot say sodium molecules because sodium is an atom. So maybe if it was supposed to be sodium hydroxide, say sodium hydroxide molecules. Please, do we get it?
Yes, please.
Okay. Does anyone have a question on this? Does anyone have a question on this? Okay. If no one has a question, then let's kindly go back to question 2. It says that how many atoms are present in 0.750 mole of iron? How many atoms are present in 0.750 mole of iron? Can we solve it? So take your Avogadro to be 6.02 times 10 to the 23. Take your Avogadro to be 6.023 times 10 to the power 23. Please, let's try our hands on it. So according to the first one that we've done, or based on the first one that we've done, let's kindly try our hands on it. Let's look at this to try our hands on the second one. Please, are we done?
Okay.
Please, are we done?
So we are almost done.
Okay.
Say,
Yes, I'm listening, please.
I got 3.115 times 10 exponent 23.
You got 3 points.
Oh, yes, 115. I'm not so sure.
So, okay. Who else is finished?
I got 4.515 times 10 raised to the power 23. I don't know.
Oh, wow. Okay. So the first person got 3 points. Let me write it, please. I'm coming. A moment. So the first person got 3.115
115 times 10. Right. Yeah,
oh, times 10 to the power what?
23.
23.
Yes.
Okay. And then the second person got
4.515
4.515
times 10 to the power 23.
times 10.
515.
Times 10 to what?
Yes, raised
23.
to the power. Oops.
Okay. Forgive my writing, okay? I'll do them well. I'll write it well. Okay. Who else is finished? Seth. Seth,
Sir.
are you done?
Yeah.
Okay, what did you get?
4.517
4.517 times
times
10 to
10.
the power.
Yes, sir.
Times 10.
No, that's all. Times 10 raised to the power 23.
23. Okay.
Yeah,
Okay, we need
Martina.
one more. We need one more answer and then we'll wrap up.
So I got 3.15.
Uh,
3.115.
Yes.
Oh, okay.
I have a partner now.
Yes, you have a partner.
Okay.
So right now, whose answer
Sir,
is right? Yes,
we are waiting for your answer.
So
I'm waiting for my
I
answer.
got 4.517 times 10 raised to the power 23.
Oh, wow. Okay, so you are now waiting for my answer.
Yes.
Sir, let's
Okay,
solve it together.
So my answer is exactly the same as Seth.
What is
4.517 times 10 raised to the power 23. Iron atoms. Seth, you are right.
Thank you.
So how did you get 3.115?
after
So wait.
4.515 and 4.517?
Yeah. I'm not saying, please. I'm not saying 4.515 is not right. It's correct. But I'm concerned about the 3.115. Can we kindly check our calculation again? So the 4.515 is right. Okay, is correct. And then 4.517 is right. But the 3.115, Abigail, did you say
Sir,
3.115?
I
No,
said
I got
sir.
the 4.515.
Okay, so who said 3.115?
Cecilia, sir.
Cecilia.
Yes, sir.
Okay, Cecilia.
Okay. So in the question, right, we using the formula, and we are using the formula. The small n was given in the question to be 0.5 mole.
No, 0.75.
0.75. Oh,
50.
Yes,
I think you want to solve the
0.7.
oxygen one.
so I actually solved the other question.
Oh, okay.
Mm,
So it's not the question 3, but rather the question 2.
Okay.
Yes. Okay, so now that you've solved the question 3, then we all know the answer for the question 3. Okay, so one person should confirm the answer for the question 3. So Jennifer, I'm sorry, Cecilia, right?
Yes, sir.
So you can also do the question 2. So
Okay.
let's now move on question 3. So Jennifer, hey, who is Jennifer here? There's no Jennifer. Cecilia, sorry. Cecilia,
Yes, sir.
you should,
Yes, sir.
yes, you should confirm for the second question, and then while we move to the third question. So please now let's move to the third question.
Okay, please.
Seth,
Sir,
are you there?
I'm here, sir.
Okay. So now let's move to the third question.
Okay.
Are we done with the third question? Okay. Cecilia, are you done with the second question?
Yes, sir.
Did you get the answer? What did you get?
4.517 times 10 exponent 23.
Okay, that's right.
Then please, which question are we solving? Isn't there how many oxygen atoms are present in 0.5 mole?
Yes, please.
Okay, so I got
That one is
3.011
5.06.
times 10 raised to the power 23.
Okay, so I think that's similarly, I mean, that's the same as the answer Cecilia gave earlier. So that's right. Okay, now let's move on to please, are we all done?
Yes. Yes, sir.
And we all got the answer, right? Did we all get the answer? Hello.
Yes, sir.
Seth, what did you get? Seth, tell me your answer. I want to know. Seth,
Sir,
what did you get?
sir, I'm not done yet.
Okay, finish it. We have to move on.
Sure, sir.
Sir, please, I have a question.
0 to
Okay, if you have a
0.
question, please ask.
Please, the second question.
Okay,
It says how many atoms are present in 0.750 mole of iron?
yes.
The symbol being Fe.
Better.
Mr. Fe. What was 55.85? Please, what does it signify?
0.5.
Oh, okay, so this
Uh,
55.85 is the relative atomic mass of iron.
Okay.
So, yes,
Sir,
you see, we
please,
have relative atomic mass of carbon to be what? 12.
okay.
Yeah, that is for iron.
Okay. Thank you.
Yes, you're welcome.
So, the question.
Okay,
So, with a question like the one you just talked about, does it mean the molecular form for the iron, it doesn't affect the solution? Hello.
doesn't affect the question. It has no problem with the question. It has nothing to do with the question. Okay,
Okay.
it's just there. Sometimes they put some of these things there to confuse students or to make you take the wrong path. But once you've worked a lot examples on what you are doing, you know what you are doing. So you are not. It's not really. You are not really affected by it. It has nothing to do with the question. Okay.
Oh, okay.
Yes. Okay, Seth, you are done, eh?
Yes, sir.
Okay, so I'm sure you got the answer. 3 point
Yeah.
either
0.
115 or
115.
3.0.
Yes, sir.
Okay, so now let's continue to the very last question. The last question, I put this there. I added a solution because it's very tricky. Oh, the last question is a little bit tricky, so I added a solution. So the question says that calculate the amount of oxygen gas in moles of 1.505 times 10 to the power 23 molecules of gas. So, and the question is saying we should calculate the amount of oxygen gas in what? In what?
More.
In mole. And what is the formula? The formula is N is equal to what? Small n
More and
times
L.
L.
Capital.
Now the question is telling us to calculate for this n. So what do we do?
Yes. We divide through by capital L.
Exactly. So we have n now. I'm sorry.
Oh,
Now we have this our n will be equal to what? Will
capital
be
N.
equal to capital N divided by what? Capital
L.
L. Yes, so let's solve it. Everyone should do it.
Okay.
I said the answer is L. Or we should do it again.
Oh, okay, yeah, I put the answer there. Yes, write it so that when you see, okay, I'm sure Mr. Isaac will share the lecture with you. But if you meet examples, some of these examples, you should have it at the back of your mind that since your capital N has been given, and the capital L has been given, or you know it, then you know that you are finding your small n because these three things are interrelated. Okay. Okay. So that shouldn't be a problem. It shouldn't be a problem. I shouldn't have put a solution there. That shouldn't be a problem at all. Now we are good with Avogadro. Do we all understand what we've done so far? Do we all understand what we've done so far?
I understand.
A second.
Okay. Seth, do you understand what you've done so far?
Yes, sir.
Okay. Please, does anyone have any question? So we can have a 2-3 minutes break. If you have any question, we bring it on board because there is more to come. There is more to do. So please, if you have any question, you bring it on. Okay. Okay. Now we are moving on to the mole itself, what we call the mole. So we started with the mole. Now we are moving on to the mole itself. So if you look at the far right of the slide, calculating molar mass from mole. So we've seen a required formula. The required formula for calculating the mole of or the amount of substance or the mole of a particular compound is small n is equal to small m over big M, where small n is equal to the mole or amount of substance. Small m is equal to the mass of the substance, and then capital M is equal to the molar mass of the substance. So the formula is N is equal to M over capital M. And then you know the parameters. This is a very simple formula that we need to keep at the back of our head. We need to know it off head because we'll be using them interchangeably. Okay, so a question says you should calculate the molar mass of 0.25 mole of it says calculate the molar mass of 0.25 mole of carbon dioxide, which has a mass of 11 grams. The formula is giving us N is equal to M over big M. And the question is telling us to find for the big M. So who can make the big M the subject of the equation? What will be our equation if you make big M the subject? What will be our...
First multiply big M and then you
So-
divide it by small n.
Yeah.
So, okay, so what will be our formula? I need just the formula.
So it will be big
Capital
M
M is
is equal to
equal to small m over n.
Abigail, you are the one talking.
Yes, please.
So you said capital M.
Is equal to small m over n.
Do we all agree? Do we all agree?
Yes, sir.
Okay, okay. So that is it. That is the right substitutions if you do the changes. So now you have your capital M is equal to small m over n. And then now the question is saying that you should calculate the molar mass of 0.25. So they gave you n to be what? Please, a minute. So you have n. You have n is equal to 0.25, right? 0.25
Yes.
more. And then small m is equal to 11 grams. So we can find for capital M. Let's try our hands on it. Everyone should try their hands on it. Let's find for capital M. We know the formula. So let's try our hands on it. If you finish your calculation, kindly raise your hand. I'll call you. Oh, okay. Abigail, your hand is up.
Yes.
Abigail, your hand is up.
Yes,
So you can
please.
talk. Yeah, you can talk.
Please, I got 44 gram per mole.
You got what?
I got 44.
44.
No, it's and
44 gram per mole.
yes, please.
Okay, so who else has an answer? Who else has an answer? Cecilia, are you done?
yes, sir.
Okay, what did you have? What's your answer?
So I got the same 44 gram per mole.
44 gram per mole. Okay, Seth. Seth, are you there?
I'm here.
What did you get?
So I'm not done. No.
Seth, you're not solving the work.
I'm sorry, sir. I can send
Okay,
screenshot to the distance. I'm
okay,
sorry.
then solve it and let's get your answer before you
Sure, sir.
continue. Rachel,
Sir.
are you done?
Yes, please.
And please, what did you get?
44 gram per mole.
44 gram per mole. Okay. Angela, is Angela here? Angela, are you here?
So it's Malcolm.
Is that
Malcolm.
okay? Mau, what did you get?
44 gram per mole, sir.
Okay. Okay, that's fine. So, Seth, I'm waiting for you. Ohima, you are also here. Seth, are you done? Seth. Okay, so the right answer is 44 gram per mole. Now, the very next question is, what is the molar mass of a compound contained in 53 grams of 0.5 mole? I'm sure you can do this too, right? Let's try our hands on it and then do the very last question and continue. So let's try our hands on the second one.
Sir,
Yes,
please, I had 106 gram per mole.
106 gram per mole.
Mm.
Rachel, are you the one that spoke?
Yes, please.
Oh, okay. Okay, 106 gram per mole. Okay, okay. Who else has an answer? Is it Lynn?
Sir,
Lynn, why did
Yes,
you
please.
do it?
I had
Okay,
106 gram per mole.
106 gram per mole. Okay.
Yes.
Mahu, did you also want to give an answer? Cecilia.
So I had the same 106
Okay,
gram.
okay. So we are all get set. Set.
Sir,
Are you there?
I'm here. I was carried away, so I'll go back and check from the link. That's why I didn't get this one.
Okay, okay. But what you
I'm
have
so
to do
sorry.
is it's not that difficult. You just
Okay.
substitute, I mean, make M the subject, and then you have to substitute the values in there to get your answer. It's not difficult, okay?
Okay, sir.
Yes. Please, do
Thank
we
you.
all understand what we are doing?
Yes, sir.
Are you
yes,
sure?
please.
Yes, please.
Okay. Okay, now let's try the very last question. A compound has its amount in moles to be 0.25. Calculate the molar mass if the mass is 8 grams. Let's do the very last one on this question.
Sir.
I'm listening, please.
I
Is
got
this Cecilia?
30. Yes. I got
32.
32. Yeah, gram per month.
Okay. Okay. Who else
So
has
I
a number?
also got 32 gram per
Okay.
month.
That's brilliant. I'm happy that everyone is getting it right. Is it Ohima that spoke?
Yes,
Or is that
please.
Big Girl? Ohima.
Yes, please.
Please, I also
Okay.
want to say 32.
Okay. Okay. Then that's fine. Then I'm very convinced that we are all on track. Little by little, we are on track, right? Okay. So now this is how to calculate for the molar mass if you have the mass and the mole of the substance or if a compound or if a particular atom. Now we are going to go the other way around. Calculating for Seth, do you have something to say?
No, sir. Sorry.
Okay. So now we'll go the other way around. Calculating for the mole or the mass if you have the molar mass or if you have the compound. And you can find for the molar mass because we've done or we've studied how to find for molar masses from the compound. So we'll go the other way around. So let's go the other way around. A minute, please. Okay. So now let's calculate for the mass. Let's calculate for the mass of the compound. If we know the mole and then we know the compound. Do you think we can do this? So we just pick our formula, which is I'm coming. Our formula, which is N, which is N. Oh. N is equal to small m over big M. Moment, please. So now we know we are finding for the mass, this. We are finding for this, the small m. What do? We just make that small m the subject of this equation. So if you are making small m the subject, just multiply here by m, capital M, multiply here too by capital M. So small m will now be equal to capital M times N. Do we get this? Do we get this?
Yes, sir.
Yes, please.
Okay. So we understand. So now we know that when or since we are supposed to find for small m, the small n, which is the mole, the amount of substance, will be given in the question, and then capital M will either be given or we'll find for it. We know how to find for capital M, which is the molar mass. So let's look at the first question. The first question says that how many grams are in 3.7 moles of sodium oxide? How many grams are in 3.7 moles of sodium oxide? So if you look at this, you know that, or you can see that they gave you the mole, which is 3.7. So N, a minute, please. N was given to be, small n was given to be 3.7.
Okay.
And then they didn't give us the molar mass, but they gave us the compound. So first of all, let's find for the molar mass of sodium oxide. Everyone should do it. Everyone should find for the molar mass of sodium oxide. If you finish, raise your hand. I'll call you. Abigail. Yeah, please, what do you
Yes,
get?
I got 52 gram per mole.
62 gram per mole. Okay. Who else? Who else has an answer? Who else has an answer, please?
62 grams per mole.
Please, I'm not hearing you well.
62.
62 gram per mole. Okay, that's right. Who else has an answer? Who has a different answer? Okay, so since nobody has a different answer, it means we are all getting 62 gram per mole. Okay, so now we have our molar mass to be 62 gram per mole. Mau, please, do you have something to say? Okay, since nobody is getting a different answer, that's our molar mass, 62 grams per mole. So now we have our mole and our molar mass. And the formula is saying that the mass is equal to the molar mass times the mole. So what is our mass? We are going to have our mass to be small m to be equal to 3.7 times 62 gram per mole. 3.7 grams times 62 gram per mole, which will be equal to, what are we getting?
209.4 grams.
What are we getting, please?
Two 229.4 moles.
Oh, yes. Sorry. No. This shouldn't be grams. This should be more. Is everyone getting 229.4 grams? Is everyone getting 229.4 grams?
Yes, sir.
Okay. So that is our answer. The final answer is 229.4 grams. Okay, now let's calculate for the next one. Calculate the mass of 0.2 mole of magnesium atoms. So calculate the mass of 0.2 mole of magnesium atoms. So try your hands on that. For magnesium, they give you the molar mass to be 24. This one, they just said magnesium atom. So it's just magnesium. You are not multiplying with anything. So you have the mass, you have the molar mass. Fine. You have the mole, you have the molar mass. Find for the mass, please.
Say
There is
4.8 grams.
4.8 grams.
Yes.
So
Okay.
please, I got the same answer.
Okay. Okay. That's fine. 4.8 grams. Okay. That's correct. Are we all on the same page, please?
Yes, sir.
Okay. Now, question 3. How many grams are in 4.63 times 10 to the power? They should be power 24 molecules of CCl4. So, how many grams are in 4.63 times 10 to the power 24 molecules of CCl4? So, let's question 3 and question 4. Question 3, question 4, and question 5. Kindly write these questions, and then we have few minutes left for the meeting to end. So please write these questions, and then we'll work on it as assignment. Question 3, question 4, and question 5. Try your hands on these questions as assignment, so that the very next time we meet for this same class, we'll attend to them. Okay?
Yes, sir.
Okay, so the question 3 is how many grams are in 4.63 times 10 to the power 24 molecules of CCl4? 24. It's not 1024, it's 10 to the power 24. And please, someone raise their hand. If you have any question, please unmute and ask, okay?
Oh, sir, my question was already answered.
Oh, okay. Okay. That's fine. So question 3, question 4, question 5, our assignment. So please, let's try hard and work on them. Finish everything. So some of them, I'm not sure you are familiar with the molar masses. You can search for the molar masses or the relative atomic masses. Something like boron, you can search for the relative atomic mass. Copper, you can search for the relative atomic mass and solve them. And then the very last question to you solve it, then you bring it. We'll discuss it in our very next meeting, okay?
Yes, sir.
Okay, so please, if there are any more questions or anyone has any question, the floor is open. You can ask your question before we end the meeting. Please, do you have any question? Mawu, do you have a question?
No, sir.
Okay. Abigail, please, do you have a question? Seth.
Sir,
Seth,
sir.
I
do you
have
have
a
a question?
question.
No, sir.
Okay. If you have a question, please ask.
No question, sir.
No question. Okay. Ohima, do you have a question?
No, sir.
Okay. Rachel,
No, sir.
Andrews, do you have a question? Okay. If no one has any question, then I think we are good. We are good for today. So please make sure you go over whatever that we've studied again, and then try so hard to resolve all these questions. And if you have your books as well, if you have your integrated science books, please go through them. You get a lot of these questions, solve or attempt them. If you find any difficulty in any question, you can jot it or write it down. When we have the next meeting, you can bring it on board and then we'll discuss it. Make sure you understand everything so that when we come again and then we are treating the next things, we don't have to really go back to what you've already treated. Okay?
Yes, sir.
Okay, sir.
So the very next meeting that we'll have, we are going to, on chemistry, we are going to move on solving or calculating the mole when we have the molar mass and the mass in grams. So that's where we'll continue from. All right. Thank you very much. Have a good evening.